Special values of complete elliptic integrals of first and second kind. Yeah. So basically, k is the complete elliptic integral of first kind, which is defined in the following way: integral from 0 to pi by 2 of 1 by root under. If this was for some random number m, then 1 minus m square sine square theta d theta. Yeah. Similarly, the complete elliptic integral of second kind is defined as integral from 0 to pi by 2 of square root of 1 minus m square sine square theta d theta. Now this integral over here is also involved while finding the circumference of ellipse. That's why it's known as elliptic integral. Now let's try to find these values. How do we deal that? So basically we just go through the definitions itself. So I is basically the imaginary number, imaginary unit, iota. Yeah. With through definition we will try to make some manipulations and we will get this result. Let's see how. So if you go from the definition, the k of I will be integral from 0 to pi by 2 of 1 by square root 1 minus I square will be minus 1, so that's plus over here, 1 plus sine square theta d theta. Now let's try to make a u substitution, that is u equals sine theta. Yeah. And that gives us theta equals to sine inverse u. Yeah. Now integral goes from 0 to 1 by root under 1 plus u square, and d theta will be 1 by root under 1 minus u square du. Yeah. And then this will be integral from 0 to 1 of 1 by root under 1 minus u to the power 4 du. Yeah. Now let's make substitution x equals to u to the power 1 by 4. That gives x to the power 1 by 4 equals to u. Yeah. And so we have integral from 0 to 1 again, and then du will be 1 by 4 x to the power minus 3 by 4 dx by, this is square root of 1 minus x. Yeah. And take the 1 by 4 outside, and we have integral from 0 to 1 of x to the power minus 3 by 4 1 minus x to the power minus 1 by 2 dx. Now this is a simple beta function. Yeah, beta of 1 by 4 comma 1 by 2. Yeah. And so we have 1 by 4, this is gamma 1 by 4 gamma 1 by 2 by gamma 3 by 4. And to simplify the stuffs, let's multiply by gamma 1 by 4 over here, so that we can use the reflection formula, because we know that gamma of n, gamma of 1 minus n is equals to pi by sine n pi. Here if 1 by 4 is n, 3 by 4 is 1 minus n, so that's why we can also use here 1 by 4. This is gamma square 1 by 4. Gamma of 1 by 2 is square root of pi, and this is pi by sine pi by 4 is 1 by root 2. That's why we have 1 by 4 square root of 2 pi, and this is gamma square 1 by 4. Yeah, gamma square 1 by 4, and this is the answer. Let's check if this is the answer or not. So basically 1 by 4 root 2 pi gamma square 1 by 4. Yeah, so this was it, and we'll also go to the another one, but before that let's talk about the flow of this. We use the definition, made a u substitution of sine theta, and then with again another substitution to simplify it, we got the beta gamma function. This was easy. Let's see how other one goes. Yeah, we have e of I, and this is now integral from 0 to 1 of root under, again m square is minus 1, so 1 plus sine square theta d theta. Now what do? We basically make a u substitution, yeah, of u equals sine theta. with that new substitution, we will have this going from now. Oh, this is from up to pi by 2. Sorry, what did I do here? Pi by 2. Fine. Now this goes from 0 to 1. Root under 1 plus u square, and d theta will be sine inverse u. Yeah, that's why d theta will be root under 1 by 1 minus u square du. Yeah, and now if we multiply numerator and denominator by root under 1 plus u square, what do we get? 1 plus u square by root under 1 minus u to the power 4 du. Yeah, now let's separate these two integrals and solve. That's an easy task. 1 by root under 1 minus u to the power 4 plus u square by root under 1 minus u to the power 4 du. Yeah, and now let's make new substitution as well. Now let's say g equals u to the power 4. Now this will again go from 0 to 1, and over here we will have 1 by root under 1 minus g. There we will have g to the power 1 by 2 by root under 1 minus g, and du will be 1 by 4 g to the power minus 3 by 4 dg. Yeah, now again we have the beta functions. 1 by 4 outside, integral from 0 to 1. Here we have g to the power minus 3 by 4 1 minus g to the power minus 1 by 2 dg. Yeah, and over here we have plus integral from 0 to 1. This is 2 by 4, so g to the power minus 1 by 4 1 minus g to the power minus 1 by 2 dg. Yeah, now you use the beta function 1 by 4. This is beta of 1 by 4 comma 1 by 2 plus this is beta of 3 by 4 comma 1 by 2. Yeah, and now this is 1 by 4 times gamma 1 by 4 gamma 1 by 2 by gamma 3 by 4, and this is gamma 3 by 4 gamma 1 by 2 by gamma 5 by 4. Yeah, and now it's about the simplification. If you multiply numerator and denominator by gamma 3 by 4. Okay, so let us check the answer if we are doing correct or not, or else it will be a mess. Okay. Yeah, okay, so let's multiply by gamma 1 by 4 in both numerator and denominator, and that gives us gamma square 1 by 4, and this is root pi, and over here by Euler's sign reflection formula, that will be pi by 1 by root 2. Yeah, over here let's multiply by, okay, so first of all let's break this gamma 5 by 4 into 1 by 4 into gamma 1 by 4. Yeah, 1 by 4 gamma 1 by 4, and then this 4 will go to numerator. Now multiply by gamma 3 by 4, that gives us gamma square of 3 by 4, and then root pi by, this will be pi by 1 by root 2. Yeah, now we are near the end. Now this is 1 by 4 root 2 pi gamma square 1 by 4 plus here 4 cancels out, and 1 by root 2 pi gamma square 3 by 4. That's the answer. Let's check if this is correct or not. 1 by root 2 pi gamma square 3 by 4 plus 1 by 4 root 2 pi gamma square 1 by 4. Yeah, basically it can also be told as this is actually k of I plus 1 by root 2 pi gamma square 3 by 4. The fact that there is k of I is really amazing. Yeah, and to talk about the flow of this problem, again just like the previous one, we first made the new substitution of sin theta and try to multiply and make this root free. Yeah, and this one as similar as earlier, but This one also we went the same way, that make g cos e to the power 4 and then beta function. That was it. It was not a hard problem, just substitution, beta functions and such stuffs. Hope you enjoyed the video. Thanks for watching. Look forward to seeing in the upcoming videos too.